In this video, we will look at using properties of logarithms to expand a logarithm. In our example, we are asked to rewrite the expression as a sum, difference, or product of logarithms and simplify if possible. So to help us out, I've put our log properties over here. You saw these in a previous video. If you have log base b of m times n, that's equal to log base b of m plus log base b of n. If you have log base b of m over n, that's equal to log base b of m, whatever's in the numerator, minus log base b of n, whatever's in the denominator. And the third property is log base b of m to the k equals k times log base b of m. So if you have an exponent on the argument, the expression that's plugged into log, then that exponent can drop down in front and just leave you with the base inside of the log. So looking at our example, we have natural log of x plus 2 times x plus 3 all over x minus 1. So the first property that I'm going to use is this second one. Log base b of m over n equals log base b of m minus log base b of n. So I'm going to go ahead and use that one first. So I have natural log ln of x plus 2 times x plus 3. And that whole expression is plugged into my log. So I'm going to go ahead and put a bracket around it. And then because the x minus 1 is in the denominator of the argument, I will have minus natural log of x minus 1. All right, now I need to use the property that if I have two things multiplied in the argument, I can split them into two logs using a plus. So I'm going to use log base b of m times n equals log base b of m plus log base b of n. So I'll have natural log of x plus 2 plus natural log of x plus 3 because they're being multiplied inside the log. So I split them apart and put a plus between. And then minus natural log of x minus 1. Now let's look back at the directions. It says a sum, difference, or product of logarithms and simplify if possible. Now, there is not really any way to simplify this. I've written it as 3 logarithms. There's no more multiplication or division or exponents inside of the argument, so inside of the logs. And so this would be my final answer. Let's look at one more example that's slightly more complicated. We have log base 4 of the 9th root of 2x minus 4 over 3x to the 5th. All right, so what I want to do is first I would want to use this quotient property, log base b of m over n equals log base b of m minus log base b of n. So I'm going to use that one first. And I would go ahead and split this into log base 4 of the 9th root of 2x minus 4 minus log base 4. Notice I'm keeping the same base when I split it. So I have log base 4 of 3x to the 5th. So first I used the quotient rule and split it into 2 logs with a subtraction between. And the denominator of the argument is plugged into the subtracted log. All right, so now I want to use exponent rules. I'm going to think back to the beginning of the class when we did exponent rules. And we have an exponent rule that says that if you have the nth root of something, so I'll just go ahead and say the nth root of expression capital A, that is the same as A to the 1 over n power. So I'm going to use that exponent rule to rewrite the argument inside of the first logarithm. So my first logarithm will be log base 4. And then this will be 2x minus 4, close the parentheses, to the 1/9 power, because I have the 9th root. And then I have minus log base 4 of 3x to the 5th. All right, so now that we have this written as an exponent, we can use this third log property, log base b of m to the k equals k log base b of m. And so that exponent is going to come down in front. So this will become 1/9 log base 4 of 2x minus 4 minus log base 4 of 3x to the 5th. So now I'm getting closer, but I'm not done yet because I have this product, 3x to the 5th. So I'm going to use the first log property to split that apart. Okay, so I have 1/9 log base 4 of 2x minus 4. So that one is done. That log is as simplified as it's going to get because I don't have a property that will split apart the argument 2x minus 4. My properties only work when I have multiplication or division in the argument, in the thing that's plugged into the log. So I'm going to have minus, I have 1/9 log base 4 of 2x minus 4 minus, I'm going to put a bracket, and then I'm going to use the product property to split apart the second logarithm as log base 4 of 3 plus log base 4 of x to the 5th. So I had that product 3 times x to the 5th, and I split it into log base 4 of 3 plus log base 4 of x to the 5th. And now I'm going to distribute my negative. So that's why I put the bracket, was so I would remember to distribute that negative. So I'll have 1/9 log base 4 of 2x minus 4 minus log base 4 of 3 minus log base 4 of x to the 5th. So now we just have to look through our logs and see if there's any more of the properties we can use. This first log, as I mentioned, is done. We don't have any exponents, products, or division inside of our argument. The second one, minus log base 4 of 3, that's simplified. We don't have any products, division, or exponents inside of the log. This third one, log base 4 of x to the 5th, we have an exponent. So that means that we can use the property where the exponent comes down in front. So our final answer is going to be 1/9 log base 4 of 2x minus 4 minus log base 4 of 3 minus 5 log base 4 of x. Now I look at all the logs. I do not have any multiplication, division, or exponents in any of the arguments. Remember, argument is the expression plugged into the log. So I can say that I'm done expanding this logarithm. And that's how you use the log properties to expand a logarithm.